The ampacity of bus bars is indeed covered in the National Electrical Code. You can find information regarding bus bar ampacity in section 368.13 of the NEC. This section addresses the requirements for busways, which include bus bars. Busways are prefabricated electrical distribution systems consisting of bus bars and a protective enclosure. The NEC provides regulations for the installation, ampacity, and protection of busways to ensure electrical safety. The specific requirements for bus bar ampacity within busways depend on factors such as the material, size, and configuration of the bus bars, as well as the ambient temperature and ventilation conditions. The NEC provides tables and guidelines for determining the allowable ampacity of bus bars based on these factors. It's important to consult the latest edition of the NEC and to work with qualified electrical professionals to ensure compliance with all applicable codes and standards when installing or working with busways and bus bars. Understanding the NEC requirements for bus bar ampacity is crucial for ensuring the safe and reliable operation of electrical systems. Now, let's delve deeper into the concept of ampacity and how it relates to bus bars, and how section 368.13 governs bus bar installations within the framework of the National Electrical Code. Ampacity, at its core, represents the maximum amount of electrical current, measured in amps, that a conductor, such as a bus bar, can carry continuously without exceeding its temperature rating. This temperature rating is crucial, as exceeding it can lead to insulation degradation, conductor damage, and potentially hazardous situations like electrical fires. The NEC meticulously defines ampacity for various conductor types and sizes, taking into account factors like the material of the conductor, its cross-sectional area, and the ambient temperature in which it operates. Bus bars, typically made of copper or aluminum due to their excellent conductivity, are essential components in electrical distribution systems, serving as common connection points for multiple circuits. Their ampacity is paramount to ensuring the system's integrity and preventing overheating. Section 368.13 of the NEC specifically addresses the ampacity of busways, which are prefabricated assemblies containing bus bars within a protective enclosure. While the section doesn't explicitly state the ampacity of individual bus bars in isolation, it provides guidelines and requirements for the overall busway system, indirectly influencing the bus bar ampacity. Firstly, section 368.13 mandates that busways be installed and supported according to their listing and labeling. This means that the manufacturer has already determined the busway's ampacity based on the bus bar size, material, and enclosure design, and these values are clearly marked in the equipment. Secondly, the NEC requires that busways be protected against overcurrents, meaning that circuit breakers or fuses must be installed to limit the current flowing through the busway to its rated ampacity. This protection is crucial in preventing damage to the bus bars and the entire system in case of a fault. Thirdly, the NEC specifies the allowable voltage drop in busway systems. Voltage drop occurs when the voltage at the load end of a conductor is lower than the voltage at the source due to the conductor's resistance. Excessive voltage drop can lead to equipment malfunction and inefficiency. The NEC sets limits on voltage drop to ensure that equipment operates correctly. Fourthly, section 368.13 addresses the grounding and bonding requirements for busways. Grounding and bonding are essential for safety, providing a low impedance path for fault currents to return to the source, tripping the overcurrent protection and preventing electrical shock hazards. The NEC mandates that busways be properly grounded and bonded to ensure electrical safety. Fifthly, the NEC covers the installation of busways in specific environments, such as damp or corrosive locations. These environments can accelerate the degradation of bus bars and enclosures, so the NEC requires special precautions to be taken, such as using corrosion-resistant materials and providing adequate ventilation. Sixthly, the NEC addresses the spacing and clearance requirements for busways. Adequate spacing and clearance are necessary to prevent overheating and to allow for safe maintenance and inspection. The NEC specifies the minimum distances between busways and other objects such as walls, ceilings, and equipment. Seventhly, The NEC covers the connection of busways to other equipment, such as transformers and switchboards. These connections must be made in a way that ensures a reliable electrical connection and prevents mechanical stress on the busway. The NEC specifies the types of connectors that can be used and the torque requirements for tightening the connections. Eighthly, the NEC addresses the marking and labeling requirements for busways. Busways must be clearly marked with their voltage, ampacity, and other important information. This information is essential for safe installation, operation, and maintenance. Ninthly, the NEC covers the inspection and testing requirements for busways. Regular inspection and testing are necessary to ensure that busways are in good condition and operating safely. The NEC specifies the types of tests that must be performed and the frequency of inspections. Tenthly, understanding the broader context of NEC Chapter 3, Wiring Methods and Materials, is essential. This chapter provides general requirements for conductors, cables, raceways, and other wiring components, which also apply to busbar installations. These requirements cover topics such as conductor insulation, conductor sizing, overcurrent protection, and grounding. Now let's shift our focus to the practical considerations for determining the appropriate ampacity for busbars in specific applications. Firstly, determine the load requirements. First step is to determine the total current that the busbars will be required to carry. This can be done by calculating the sum of the currents of all the circuits that will be connected to the busbars. Secondly, consider the ambient temperature. The ampacity of busbars decreases as the ambient temperature increases. Therefore, it's important to consider the ambient temperature in the location where the busbars will be installed. Thirdly, account for dirting factors. Dirting factors are used to reduce the ampacity of busbars in certain situations, such as when multiple conductors are bundled together or when the busbars are installed in a confined space. Fourthly, select the appropriate busbar size. Once the load requirements, ambient temperature, and dirting factors have been considered, the appropriate busbar size can be selected. The busbar size should be large enough to carry the required current without exceeding its temperature rating. Fifthly, ensure proper installation. Proper installation is essential to ensure that busbars operate safely and reliably. Busbars should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. In addition to Section 368.13, other sections of the NEC may also be relevant to busbar installations depending on the specific application. For example, Section 310.15 provides general requirements for conductor ampacity, which may be applicable to busbars that are not part of a busway system. Section 250 provides requirements for grounding and bonding, which are essential for ensuring electrical safety in all electrical installations. Section 408 covers switchboards and panel boards, which often incorporate busbars as part of their internal construction. Furthermore, it's crucial to stay updated with the latest edition of the NEC as codes and standards are periodically revised to reflect new technologies, safety concerns, and industry best practices. Consulting with qualified electrical engineers and licensed electricians is always recommended to ensure compliance with all applicable codes and standards and to ensure the safe and reliable operation of electrical systems incorporating busbars. In conclusion, while Section 368.13 of the NEC specifically addresses busways, it indirectly governs the ampacity requirements for busbars within those systems. Understanding the broader context of the NEC, including Chapters 2, 3 and 4, and consulting with qualified professionals are crucial for ensuring the safe and compliant installation of busbars in any electrical application. Remember that electrical codes and standards are constantly evolving, so continuous learning and professional development are essential for staying up to date with the latest requirements and best practices.